Welcome back to the deep dive. Today we are looking at something that, honestly, it isn't just another version number.
Right.
It's not just a slightly higher benchmark score. We're really looking at a fundamental shift in how open source AI is being architected right now.
Absolutely.
We're unpacking Meta's release of the Llama 4 herd. And I want to be clear with you right off the bat, if you're listening, this is not just a standard software update. It feels like a philosophical pivot.
It really is. I mean, for the last few years, the race has just been about parameters. Bigger is better, throw more compute at it, build the giant Godzilla model.
Yeah, exactly.
But with this Llama 4 technical release, Meta is effectively saying the era of the monolithic do-it-all model is ending. They're replacing it with specialized efficiency.
Right, and they literally call it a herd.
Yeah.
We have the actual foundation paper right here in front of us. It's titled The Llama 4 Herd, the beginning of a new era of natively multimodal AI innovation.
Yeah.
And that native part is going to be key.
Huge. We will definitely get into that.
But let's start with the mission for today's deep dive. We need to unpack how these models manage to beat competitors like GPT-4o and Gemini 2.0 while actually being smaller and more efficient.
Which is a massive claim to make.
It is. And we are looking directly at the official Meta technical release from April 2025. This has all their architecture details, their training recipes, the benchmarks. We're going to cover the high-level strategy of why herds matter, but also get into the technical nuggets.
Right. Things like what iRoPE is and why removing your easy data actually makes your AI smarter.
Yes, the data pruning section is just wild. But let's start with the models themselves. The herd concept. Meta didn't just drop one model, they dropped 3 specialized ones.
Right. We have Scout, Maverick, and the Behemoth.
Let's look at Scout first.
Yeah.
Because the specs on this one just seem almost impossible for its physical footprint.
Scout is absolutely the disruptor here. It's designed specifically for efficiency. The paper lists it as having 17 billion active parameters.
Okay, but it has a total parameter count of 109 billion.
Yeah. Exactly. And we really should pause on that distinction between active and total parameters because it's the core of this whole release.
Yeah, for the listeners, this is a mixture of experts architecture, MOE. We know it uses routing, but how is Llama 4 implementing this differently than older models?
So if you look at a standard dense model, every single parameter is active for every single token it generates.
Which is computationally exhausting.
Highly exhausting. It requires massive clusters of GPUs. But in Llama 4, they're using alternating dense and MOE layers.
Okay, so how does that work for Scout?
Well, Scout has 16 experts. When a token comes in, the router doesn't wake up the whole brain. It routes the signal only to the specific expert layers that are best suited for that specific concept.
Which is why you have 109 billion parameters of total knowledge stored, kind of like on disk, but you're only paying the compute cost for the 17 billion active parameters during inference.
Right. And the implication of that is just staggering. Scout fits on a single NVIDIA H100 GPU.
Just one card.
Just one card. You don't need a server farm.
That is the headline right there for enterprise users. But it's not just small, it's punching way above its weight class.
Oh, it's beating Gemma 3, it's beating Gemini 2.0 Flashlight, and Mistral 3.1.
But the real wow factor for Scout, the thing that makes you stop scrolling when you read the paper, is the context window.
10 million tokens.
10 million. I mean, we've seen big numbers before. Gemini 1.5 Pro hit some high numbers, but usually the performance degrades.
You get that lost in the middle phenomenon.
Exactly. The model just forgets what was on page 5 of the document. So what is Scout actually capable of doing at 10 million tokens without losing the plot?
At 10 million tokens, you aren't just giving it a PDF to summarize. You are feeding it an entire corporate repository of code. You're giving it years of Slack history or massive legal discovery archives.
And because it fits on one GPU, you can do this locally.
Exactly. You don't have to send all that highly sensitive corporate data up to an API cloud.
That's a total game changer for privacy-focused industries like healthcare or finance. Now, moving up the food chain, we have Maverick.
Maverick is the smart workhorse. Now, it has the exact same active parameter count as Scout 17 billion.
So it's still incredibly fast.
Very fast. But it has way more experts. It's sitting at 400 billion total parameters with 128 experts.
So it has vastly more knowledge stored up, but it's theoretically just as fast to run as Scout.
Roughly, yes. And this is the model where Meta is targeting the big guns. They explicitly claim Maverick beats GPT-4o and Gemini 2.0 Flash.
And they have the receipts. The paper shows it achieving an ELO score of 1417 on El Marina. That puts it right at the absolute top of the leaderboard.
And for any developers listening, the technical release notes that Maverick is comparable to DeepSeek V3 on reasoning and coding tasks.
But with half the active parameters.
Exactly. The efficiency curve they've achieved here is incredibly steep.
It really is. But we have to talk about the third model in the herd. The one you probably won't run at home, but the one that makes the others possible.
The Behemoth.
The teacher.
Right. Behemoth is massive. We are talking about 288 billion active parameters and nearly 2 trillion total parameters.
2 trillion.
Yes. At the time of this source text, they noted it was still training, but it was already outperforming GPT-4.5 and Claude Sonnet 3.7 on STEM benchmarks.
But its primary role isn't really to be a consumer product, right? It's a generator.
It's used for distillation. They literally used Behemoth to teach the smaller models. They used it to generate high-quality synthetic data to train Scout and Maverick.
The master creating the apprentices.
Exactly.
We're definitely going to circle back to the implications of that at the end of the show, because training AI is a wild rabbit hole. But I want to pivot right now to the native multimodality aspect.
Oh, this is a fascinating part of the paper.
It is. The paper emphasizes this heavily. And you might be thinking, well, we've had multimodal models for a while, GPT-4v, Gemini. So why is Meta calling Llama 4 a new era of natively multimodal AI?
It comes down to the architecture, the difference between early fusion and late fusion. In the past, a lot of these multimodal models were essentially two different brains hot-wired together.
Like a Frankenstein setup.
Kind of. You'd have a vision encoder, often called a tower, that looks at an image, turns it into a mathematical representation or even text, and then shoves that translated data into the language model.
So the language model isn't actually seeing the image. It's just reading a text translation of the image that the vision encoder handed to it.
Precisely. And just like any translation between two languages, you lose a lot of nuance. It's a lossy process. But Llama 4 uses early fusion.
Which means what exactly for the training phase?
It means they pre-train the model on text, images, and video simultaneously, using one unified model backbone.
So when Llama 4 processes an image, it's not relying on a translation. It's processing the visual tokens right alongside the text tokens in the exact same thought process.
Yes. The model natively understands that a cluster of pixels representing a cat and the text word cat share the exact same semantic space.
And the paper mentions they used a vision encoder based on Metacalypse for this, right?
They did, but they trained it separately with a frozen Llama model to adapt it perfectly to this early fusion setup.
So what is the practical upside of this for you as a user? Is it just faster, or is it actually more capable?
It's significantly more capable at reasoning. The paper highlights a feature called image grounding. This is a massive leap.
Explain grounding.
So imagine you show the model a highly complex diagram of a car engine, and you ask it, where is the intake manifold? Older models would just give you a text description of where it is.
Right, like it's on the left side near the top.
Exactly. But Llama 4 doesn't just describe it. It can output the specific pixel coordinates, a literal bounding box around that specific part of the image.
It can literally point to it.
It points. It localizes objects of interest. And you can't fake that. That requires a deep native understanding of the relationship between visual data and linguistic concepts.
You definitely can't do that accurately with a bolt-on vision tower. Plus, the source notes it can handle multi-image inputs and video frame stills.
Yeah, they tested it successfully with up to 8 images in post-training.
So you could feed it a video of a software user interface that's glitching out, and it could reason across the timeline of those frames to diagnose the bug.
Absolutely. And because of that massive context window we talked about, it can hold an incredible amount of those video frames in its memory all at once.
Okay, let's go back to that context window for a second, because 10 million tokens is a lot of memory to manage. Technologically, how do you prevent the model from hallucinating or losing track of position 1 versus position 9 million?
The technical unlock there is something called iRoPE.
Interleaved rotary positional embeddings.
That's the one. This is a very clever fix for a classic transformer problem.
Let's break that down for the audience. Standard positional embeddings are just the tags that tell the model the order of the words, right? Like this word comes after that word.
Right. But the math for those standard embeddings tends to degrade when you stretch them out over millions of tokens.
The model literally forgets where it is in the sequence. It loses its place in the book.
Exactly. So iRoPE changes the mechanism. Instead of just adding a static position tag, it actually rotates the vector representation of the token in a way that encodes its relative position.
And the interleaved part of the name.
That means they use attention layers without these positional embeddings and mix them in with layers that do have them. This interleaving is what supports their goal of essentially infinite context links.
It sounds like they're building a much more robust coordinate system for the data so it doesn't get lost.
That's a great way to put it. And they pair this iRoPE architecture with something called inference time temperature scaling.
Temperature in AI usually means creativity, right?
Yes, how random or creative the model is allowed to be. With this scaling method, the model dynamically adjusts its own temperature based on how long the context is.
Oh, that makes sense. So if it's reading a massive 10 million token legal document, it tightens up that temperature to ensure it's retrieving facts perfectly accurately.
Exactly, rather than getting too creative and hallucinating a clause in a contract that doesn't exist.
So it knows when it's supposed to be a poet and when it needs to be a strict librarian.
That is exactly what it's doing.
All right, I want to get into the part of the paper that honestly blew my mind the most.
Yeah?
The training recipes.
The data diet.
Yes. Usually, the conventional wisdom in AI is that data is king. You just scrape the entire internet, you feed the beast as much text as possible, and it gets smarter. But Meta explicitly states in this release that they deleted huge chunks of their training data to improve performance.
It completely challenges the scaling laws everyone talks about. So they started with a massive mixture. 30 trillion tokens spanning 200 languages.
Which is 10 times more multilingual tokens than they used in Llama 3, just for context.
Right. And they used a new technique called MetaP to set hyperparameters that transfer well across these different model sizes. But the real breakthrough happened during the post-training phase.
Supervised fine-tuning, or SFT, and the direct preference optimization, DPO.
Yes. During those phases, they realized something incredibly counterintuitive. They found that standard SFT and DPO processes were actually over-constraining the models.
Over-constraining them how? Like making them too rigid?
Think about it in terms of easy data. If you show a model millions and millions of examples of 2 + 2 = 4, or the capital of France is Paris.
Basic trivia.
Right. The model just learns to memorize. It optimizes for the quick, easy answer. It doesn't actually have to engage its deeper reasoning circuit.
Like a student who just memorizes the flashcards for the test, but then completely fails the long-form essay question because they don't actually understand the concepts.
Exactly. So by feeding the model all this easy data, they were effectively training it to be lazy.
So they just cut it out.
They pruned it aggressively. For the smaller models, they removed 50% of the data tagged as easy.
That's half the data just gone.
But for the Behemoth, the massive teacher model, they removed 95% of the supervised fine-tuning data.
95%. They essentially threw out the entire standard curriculum and just kept the hardest final exams.
They only kept the complex math problems, the highly nuanced coding challenges, the multi-step logic puzzles, and the result was incredible. By forcing the model to only train on the hard stuff, it couldn't rely on simple pattern matching anymore.
It had to actually learn to reason from first principles.
Exactly. It proved that focusing only on the hard stuff made the models remarkably smarter.
That is such a fascinating validation of quality over quantity. It's not just about how many trillions of tokens you have, it's about how hard those tokens force the model to work its reasoning muscles.
And they took it a step further. They combined this pruning with a strategy called continuous online RL reinforcement learning.
How did that work in practice?
They alternate between training the model and then actually using that newly trained model to filter the next batch of training data.
Oh, wow. So it's actively curating its own study materials.
Right. And it only keeps the medium to hard prompts for the next round. It's a self-reinforcing cycle where the model constantly raises the bar for itself as it gets smarter.
That is brilliant. Now, speaking of behavior and how these models are trained, the paper touches on something that usually gets buried in PR speak: bias and safety.
Yes, and they were surprisingly direct about it.
They really were. We need to touch on this because the source material brings it up explicitly. And just a reminder for our listeners, we are just imparting what's in the Meta release here, not taking a stance on it. But Meta admitted in the technical paper that large language models have historically leaned left on social topics.
They didn't dance around the issue at all. They stated clearly that this bias is a direct result of the internet training data itself.
Right. The corpus of the internet leans a certain way. So how did they address it? Because you can't just delete the internet. Did they try to hard code a counter bias to make it lean right?
No, and that's a really important distinction. They didn't try to engineer a right-leaning model to balance the scales. Their goal was to engineer a neutral and highly responsive model.
Meaning it actually answers the user instead of lecturing them.
Exactly. The source notes that Llama 4 refuses prompts much less often. The refusal rate dropped from 7% in Llama 3.3 down to less than 2%.
So it's way less likely to hit you with that standard, I am an AI and I cannot answer that boilerplate text.
Correct. And when they tested specifically for political lean, they found that Llama 4 responds with a strong political lean at half the rate of Llama 3.3.
The paper actually benchmarks it against Grok, right?
It does. They noted it's comparable to Grok in its ability to handle sensitive topics without inserting a strong political bias.
But obviously, you can't just lower refusal rates to 2% and just hope for the best regarding safety. You need to know the model won't happily write a recipe for a bioweapon.
Right, which brings us to GOAT.
Generative offensive agent testing.
It is such a cool concept.
It sounds like a specialized AI SWAT team.
That is exactly what it is. In the past, automated red teaming, testing the safety of a model, relied heavily on humans trying to trick it.
Which doesn't scale well. Humans get tired. They run out of creative ways to jailbreak the system.
Exactly. So Meta built these adversarial AI agents. They are programmed to act as medium-skilled adversarial actors.
So it's AI aggressively attacking AI.
Yes. These Duite agents just relentlessly attack the Llama model. They try to jailbreak it. They try to extract dangerous information. They try to force it to show bias. And they can run millions of attack vectors an hour.
Which completely frees up the human safety experts.
Right. The humans don't have to do the repetitive volume attacks. They can focus their time on finding the really novel edge case vulnerabilities, the unknown unknowns.
That seems like a much more robust way to safety check a model, especially one with a 10 million token window where an attack could be hidden anywhere in a massive document.
It's totally necessary at this scale.
So let's bring this all together for you listening. We have this herd strategy of specialized, efficient models. We have native multimodality through early fusion, a 10 million token context window unlocked by iRoPE, and this totally counterintuitive training methodology that cuts out 95% of easy data to prioritize difficulty over volume. When you look at this entire package, what is the big takeaway for the industry?
The takeaway is that the traditional moat is gone.
The moat being the massive compute clusters.
Exactly. For a long time, the assumption was that only the tech giants with the biggest server farms and the most proprietary data could win this race. But Llama 4 proves that with a smart architecture like MoE and incredibly smart data selection like the pruning we discussed, you can beat the giant models on consumer hardware.
Because Scout and Maverick are open weights. They're out there.
Yes. This decentralizes state-of-the-art intelligence.
It literally puts the reasoning power of a GPT-4 class model onto a single local GPU.
Or laptop, eventually.
Or into a local hospital server that isn't allowed to connect to the cloud. Or law firm's basement. It moves AI from a service you have to rent to an asset you can actually own and run locally.
That is huge. But before we wrap up, I want to end on one specific kind of provocative detail we touched on earlier.
The Behemoth.
The teacher model. We established that the best models in this new herd Scout and Maverick were trained on synthetic data generated by Behemoth.
Right, the distillation process. Behemoth generated the data and the targets to train the smaller models.
This feels like we are crossing a major threshold. I mean, for decades, the entire paradigm of computing and AI has been humans generate the knowledge and AI learns from the humans. We write the articles, the AI scrapes them. But here, Meta is explicitly stating in their foundation paper that their best, most efficient models are largely the products of AI-generated supervision.
It is absolutely a threshold moment. We are shifting away from an era where human data is the primary fuel. So human data is just the seed now.
Just the seed.
If the teacher is an AI and the student is an AI, and we know the student models are getting more and more efficient, eventually the student surpasses the teacher. Are we looking at the actual beginning of recursive AI intelligence?
That is the logical endpoint of this technical release. If Behemoth is what makes Maverick smart today, eventually a future version of Maverick helps build the next Behemoth.
The feedback loop just gets tighter and tighter.
Exactly. We very well might be looking at the last generation of models that relied primarily on human-generated text to get smarter. What happens when the teacher is no longer human?
The baton is officially being passed.
And Llama 4 is the handoff.
That is a heavy, fascinating thought to leave you with today. Llama 4 is out, the weights are available, and the era of the herd and AI teaching AI is officially here. Thank you for joining us on the deep dive. We'll see you next time.
Thanks for listening.